Alright, so today we're going to look at extreme and average rates of change, analyze increasing and decreasing behavior. So the first one, it says use the graph of each function to estimate intervals to the nearest 0.5 units where the function is increasing, decreasing, or constant. Support the answer numerically. Alright, so whenever you read the graphs, you always want to read from left to right. So always start with the farthest left point or left part of the graph, and then just imagine drawing the graph with your pencil. Okay. So here's the function x squared minus 4. If we put our pencil at the farthest left and just follow the graph, notice that our pencil is going down, 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 down. It's decreasing, decreasing until it gets to the vertex, right? And then it starts increasing as we keep following it. So it decreases until boom. And you want to look at the x. So right here, go up to the x-axis, and we have 0. Okay. So it looks like it's decreasing until 0. So what we want to do, so f of x is decreasing. And then here's the interval. So from the farthest left, negative infinity, to that point. And we're going to learn later that's the extrema. Okay, it's either maximum or minimum. In this case, it's minimum. All right. So it's decreasing from negative infinity from the farthest left all the way to this point, 0. All right, and then f of x is increasing. So it's going back up from 0 to infinity, positive infinity. And there we go. All right, now to support it numerically, we're going to plug it into our calculator. All right. So I'll just show you one again. Oh, so first we need to put the x's. So we want 0 to be, since we only have one change, or one extrema, we're just going to put that 0 in the middle, and we're going to do two numbers that are smaller. So negative 1, we can use negative 2 if we want, negative 2. We have positive 1 and positive 2 on this side. So let's plug in negative 2. Alright, so here's our function. We have a squared, so that means we need to make sure that it's, Alright, sorry about that. So we're just going to plug in negative 2, and because of that square, we're going to put parentheses. So parentheses, and then negative 2, so 2, and then the negative sign, close parentheses, and then square. So x squared, oh, right there. So x squared, and then minus 4 equals, and 0. Alright, and I'll do the rest. And there we go. So we have 0, negative 3, negative 4, negative 3, and then 0. Okay, and going from left to right, so this is from negative infinity all the way to 0, right? Notice how it's decreasing, it's getting smaller and smaller, and then from 0 to positive infinity, notice how it's getting bigger and bigger. -4, -3, 0, and it just gets bigger from there. Alright, and the next one, we have negative f of x equals negative x cubed plus x. So we want to find our where it's increasing and decreasing. So again, we're going to start at the very left of the graph, and then just trace the graph with our pencil. And what's it doing? It's going down. And looks like it goes down till there. So that's in between 0 and 1. So we're going to say about 0.5. So f of x is decreasing. And then we start at the very farthest left, so it's negative infinity, and goes to, we said 0.5. All right. And then we want to keep on tracing the graph with our pencil. And notice how it goes up from there, but then it stops right here. Oh, sorry, that's negative 0.5. And what is this point right here? 0, 1, so this must be negative 0.5. Alright, so f of x is increasing, and that was increasing from negative 0.5, interval negative 0.5 to positive 0.5. And then from there, it goes down. Alright, so it's decreasing an interval 0.5 to positive infinity. Alright, and notice how in the previous problem we had two, one decreasing and one increasing. Here we have three, decreasing, increasing, and then decreasing again. And that's because we have these two extremas here. So we're going to have three decreasing and increasing. Here we have one extrema. So here we're going to have two. Okay, so it's always going to be one more than the extrema. And we'll talk about extremas later on. But here, we want to use these points. So we want to use negative 0.5, and we want to use positive 0.5. Okay, those are the 2 points that we used there. So we need an x that's smaller than negative 0.5. We can use 1, negative 1, or we can go bigger, let's go negative 2. Alright, doesn't matter. So let's go negative 1. And then we'll go in a point in between negative 0.5 and 0.5, 0. And then we're going to put a point bigger than 0.5, and we're going to use 1, we can use 2, whatever. Let's use 2 since we used 1 before. Okay, so now we plug it in. Same thing as before. All right, so we have parentheses, negative. I will put that negative later. So parentheses, can I do the negative now? Oh, I don't know. Negative 1. So parentheses, 1, and negative, close parentheses, cubed, shift. Alright, and then that's going to be the negative of that, so let's make it a negative. And then plus, and then negative 1. Ta-da! 0, which is what it looks like according to the graph. I'll do the rest there. Alright, and then if we look at this, right, notice as we go towards negative 0.5, it gets bigger. So 0 and then, smaller. So 0 and then negative 0.375. And then from 0.5 to negative 0.5 to positive 0.5, it's getting bigger, it's increasing. It goes to 0 and then 0.375. Didn't increase much, but after that, it decreases. So if we go to 2, notice that it goes all the way to negative 6. So it looks correct. All right, and now we're going to look at estimating and identifying extrema of a function. Remember, extrema are local minimums, maximums, local minimums, local maximums. Okay, so here, notice that it says estimate to the nearest 0.5 unit and classify the extrema for the graph of f of x. Support the answers numerically. So we want to look for any of the turning points. So extrema are the turning points where it goes from decreasing to increasing, or from increasing to decreasing. Here's decreasing, 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 boop. So here's an extrema. All right, so we'll find out what that is, and then increasing, and looks like it's a little bit constant here, but not too much. Increasing still, and then boom. And there you have another one. So 1, 2, and then keeps decreasing after that. So let's find out what this point is. Go to the x. All right, so here we have to find out how it's scaled. So notice that there's 1, 2, so we have 2 spaces, and that space is 4. So 4 divided by 2 is 2. So it's going by 2, so this is negative 2. So in between 0 and negative 2, I'm going to guess that's negative 1. So this is called a relative minimum. Remember, minimums are a low point, and the maximums are a high point. Right, so that's a minimum there. I'll do minimum at x equals negative 1. And we have this one, maximum, relative maximum. And x equals, and be careful, this is scaled by 2, so x equals 2. Ta-da! Alright, and support the answer numerically. Again, we're just going to make a table. So we want to put negative 1 here. We're going to put negative 2 here, because we need at least 1 point. It's better to do more, but we're just going to do 1. Okay, so 1 point less, and then 1 point greater, or in between, and then 1 point greater. So smaller, oh sorry, that's a positive 2. So a point smaller than negative 1. Let's go with negative, I don't know, let's do negative 2. And then a point in between negative 1 and negative 1 and 2. So we could choose 0, 1, 0 is the easiest. And a point after 2 or bigger than 2. So we could say 3, we could say 4. Okay, let's do 3. And again, we're just going to plug that into this massive function right there. Oops. Alright, so we're going to do negative 2. So parentheses, negative 2, or 2, negative, close parentheses, then we have x to the and here's my X to Y button. And then we want to put 5. And then we can put equals so that we can, and let's do the negative. And then plus, and then parentheses, 2 times, parentheses, and then negative 2, so 2, negative, close parentheses, X to Y, 4, and close parentheses, plus 3, open parentheses, 3 times, open parentheses, 2, negative. Yeah, so it's a lot easier on the computer, on Desmos. Close parentheses, and then cubed, shift cubed, close parentheses, minus, open parentheses, 4 times, open parentheses, 2, negative, close, squared, close, plus 3 times negative 2, which is negative 6, so 6 negative equals 18. And there we go. Alright, so the table verifies this, supports what we had here. So notice that as it goes to the relative minimum, alright, is decreasing, and then it increases in between the relative minimum and the relative maximum. It's increasing, goes to 0, and then 14, and then it goes down at negative 3. Alright, so now we're going to approximate the extrema, the minimum and maximum, and we want to approximate to the nearest hundredth. Alright, so they gave us a function f of x equals x to the fourth minus 5x squared plus minus 2 plus 2x plus 4, and state the x values where they occur. Okay, so if we zoom out here, I plugged it in already. That's what our graph looks like. And the nice thing about this is as long as you touch it, it gives you important points. So here we have our extrema. First one is negative 1 point. So we have a relative minimum at negative 1.47, comma 0.8, and here it says 0.5, but we're going to round to the nearest hundredth, like it says, so that's the second place. Alright. And then we have the relative, not that one, that's the y-intercept, the relative maximum is negative 0.20, comma 4.20. And then deselect those. The next one. So these are x-intercepts here. Okay, not what we're looking for. We're just looking for extrema, minimums and maximums. Here's another turning point, another minimum. relative min at 1.67, comma, negative 5.51. And that's it. Alright, and now you want to find the average rate of change. It says find the average rate of change of f of x equals negative 2x squared plus 4x plus 6 on each interval. So these aren't points. We have the brackets. So that tells us that this is an interval from negative 3 to negative 1. Alright, and it includes all the real numbers in between there. So what we want to do for these rate of change, remember, it's like the slope. So we're going to use that slope formula, m equals y2 minus y1 over x2 minus x1. Alright, but we don't have y2s or y1s, we have f. Alright. So we need to find those y's or the f of x's. So we need to find f of x when x is negative 3. And we have negative 2 times, we just plug that in, times negative 3 squared plus 4x, so 4 times negative 3 plus 6. Negative 3 squared is going to give us positive 9 times negative 2 is negative 18. Right, negative 18 minus 12 is going to give us negative 30 plus 6, so negative 24. Alright, and then we want to do the same thing here with the other one, negative 1. So we have negative 2 times negative 1 squared plus 4 times negative 1 plus 6. Negative 1 squared is positive 1 times negative 2 is going to give us negative 2, and 4 times negative 1 is negative 4, so negative 2 minus 4 is negative 6. Sorry, and negative 6, and then we have plus 6 is going to give us 0. Alright, so now y2, so m equals y2 is going on the right, so let's do 0 minus y1, which is negative 24, all over the x's that correspond to them. So we use 0 first, so our first x is negative 1. Minus, and then we use negative 24. The x for that was negative 3. So minus negative 3. We get 0 plus 24 over, and then negative 1 plus 3 is going to give us 2, positive 2. 24 divided by 2 is 12. Alright, and then we want to do the same thing with 2 and 5. So write the function, but here let's use these points. So f of 2 equals, and same function, negative 2 times 2 squared plus 4 times 2 plus 6. So 2 squared is 4 times negative 2 is negative 8. 4 times 2 is 8, so negative 8 plus 8 cancels out, and we're left with 6. Alright, and then our other relative min or max, so their extrema is 5, so we're going to substitute 5 for those. Five squared is 25 times -2 is -50, and 4 times 5 is going to give us 20. So -50 plus 20 is going to give us -30 plus 6, -24 again. Alright, and there we go. Oh, so that's how we find the y's. Now let's plug it in to find our average rate of change. So we have y2, -24, minus our y1, which is 6, all over our x was 5, when y was -24, and minus our x of 1, so 2. And that's that. And the last one says find average speed. The formula for the distance traveled by falling objects on the moon is d of t equals 2.7 times 10t squared, where d of t is the distance in feet and t is the time in seconds. So distance and time. Find and interpret the average speed of the object for each interval. So this is just like what we did over here. Alright, so we're looking for the average speed or average rate of change. Same thing, so we want to find d of 1. We have 2.7 times 1 squared equals 2.7 times 1, which is 2.7. Alright, and then we're going to do d of 2. So 2.7 times 2 squared equals, so we have 2 squared is 4 times 2.7, so 4 times 8 is 28. Okay, 2, 4 times 2 is 8, plus 2 that we carried. So we have 108. Alright, and since we have 1 decimal place there, we need 1 decimal place here as well. Alright, and now we just plug into that slope formula. So I have 10.8 minus, 10.8 minus 2.7 all over the extra 10.8 is 2 minus our x for 2.7 is 1. So we have 8.1 over 1, it's just 8.1. And the same thing with the 2 to 3 seconds. Start with the 2, so d of 2 equal 2.7 times, 2 squared, and that one we already know is 10.8. And then the next one, we have d of 3. So we have 2.7 times 3 squared. So 3 squared is going to give us 9. 9 times 2.7, 24.3. Alright, so we have slope is, or average rate of change is 24.3 minus y1, just 10.8, all over x2 is 3, and then the x1 is 2. And that's it. Alright, so this one is saying, so it's supposed to interpret them by, so we're going to interpret it. So this one, from 1 to 2 seconds, average rate of change is positive 8.1. Alright.